Welcome everyone. We're going to wait a little bit longer. I have a feeling that 6 a.m. Sorry, 6 a.m. is definitely too early. I think 6 p.m. is way too early by the looks of it. So we might do this as a 6:30 class. I think the students have voted. I'm going to change the time to 6:30 because I think 6 a.m. might be a bit too early for you guys. And I understand, fair enough. So I'm going to change it. I think I'll change the other classes to 6:30 too. So we're going to wait just a little bit longer. Maybe we'll give it another 5 minutes. The people that are in this room, can you log into your virtual machines and start playing with the labs, just so you're not wasting any time. And then I'm going to talk to you about some different things I have for you today. Not necessarily about this, just about this topic. I've got some other things I wanted to have a chat to you all about what's going on in the cybersecurity world. Some cool things happening, some concerning things, some things I've learnt today. So yeah, we're gonna have a good time today. But I'll be back in about 3 minutes. Thank you guys. All right, welcome everyone. So we've only got 3 people in this room. It's very, very disappointing. So hopefully we'll change the time maybe to 6:30, but it's really disappointing. I was hoping to get more people in the room. So I'm going to change the time to 6:30 from now on. But attendance to these labs is really important. It's very critical. I really want you to come in, and I understand that people might come late. Just if you can communicate, let me know. That's fine. But that's okay. We're going to start now. So what I want everyone to do is fire up their labs. Everyone get their labs up and running. I'm going to do that as well. Just in case you missed the last lesson and you don't know how to start the lab, it's pretty easy. Go labs.azure.com/virtual machines and click on that button. And so we're going to start that lab. Should take a couple of minutes. So in the meantime, yes, please come to these lab sessions, not just watch them later on. It's not just the labs, it's other things that you might miss out on. You might there might be some announcements or something important. For example, there's been some issues with the assignments that I've noticed. I just want to go over this while this lab is loading. So this is in regards to this over here, the self check-in. Now, right there, okay. So I'm just letting you know that I have configured this in a way where you should be able to view this in after you attempted the quiz, right? So it's the settings there. Only once after it. So after each attempt, you'll see it only the once. You can't go back to it, but at least you'll be able to see it. So there is an issue with that. People are not able to see their results as promised. If over here, it is not reviewed by your OLA, and you will receive your results upon submission. So you are entitled to that. Okay. So I'm gonna send off a IT support ticket for that one. Hopefully that'll get fixed. But I just letting you know that I've encountered this before in another unit, and they never fixed it. So just expect that you might not be able to see those answers when you've submitted the quiz. But I'm going to do the best I can. I'll do the best what I can. And just remember, it's not the teacher's fault. It's not our fault. Okay, this is a technical issue. So, but we will do everything we can to fix this. Myself and the lead unit coordinator. We're going to work really hard to get this done, to get this fixed for you. If it can be done, it will be done. I promise. Well, I can't really promise that because I don't work in IT, but we'll do the best we can. All right, so how is our virtual machine running? Okay, great. So we're going to whack that there, that virtual machine connect to the virtual machine. Now I'm still getting messages. I'm still getting people sending me messages, even though I've addressed this like a few times, just in case you didn't get it. Okay, with the login right here, you don't have to put your, so when you do more choices and use different accounts, you don't put your student name in. It's not your student name that you put in here. It's here, this guy over here. See that one there? Student. It's not that clear, and that's the password there. But I did mention this a few times. Never mind. Now we've clarified that, made that crystal clear. Student and password. PIN. $, word. Don't worry about remembering, it doesn't work anyway. So that will fire up. This is what you should see there. Now I was on a firewall trying to do this, and it didn't work through the firewall, so I had to take the firewall off. So if you've got any VPNs, so not firewall, sorry, VPNs. So if you've got any VPNs, you might have to turn them off, unfortunately, which I think is not very good to turn your it's not good to turn your VPNs off. You should have a right to your VPNs, but yeah, it won't work. I've even tried it on an Australian VPN. I don't know, for some reason it just didn't work for me. Never mind. So this is our virtual machine. Welcome, Vanny. Welcome. Nice to meet you. Thanks for coming. All right, so now let's have a look at our lab task for today. So we're going to look into VirusTotal, Malware Bazaar, and the MITRE ATT&CK framework as well. This is going to be fun. So I'm just downloading the labs now. Okay, outstanding. So I'm looking at the lab. So hopefully you all have the lab as well. There's a couple of points here. The purpose of this lab is that we're going to use various online tools that can help us in our malware analysis task. Although numerous tools provide a range of features and capabilities for malware analysis, the design of this lab is to try and make this easy for you. We're not going to use all the possible tools out there, but the most popular ones out there. Now, there are different ways that you can generate a hash of a file. There is one way there that's being suggested using the hash calculator. But do you mind if I show you? Can I show you a PowerShell way of doing this? I'm going to show you a PowerShell way of doing this. So you can use this tool, this hash calculator, no problems. I'm going to show you something different. So I'm going to come into here. I'm going to right click. I'm going to create a text document. I'm just going to write blah, blah, blah in there. I'm just going to create this random file. Nothing major, just my weird sense of humor. Just generating some data in there. Okay, I'm going to save that, and that's it. I'm going to cut that, and I'm going to put this in a C drive. I'm just going to whack that in here into the C drive, and I don't want to do a folder. Delete that. I want to paste that in there. Yeah, okay. So what I'm going to do is I'm going to use PowerShell to generate a hash of that file. I want to show you how to do that, just in case you don't have access to the internet and you can't download a tool. You've got PowerShell, your best friend. It'll generate that for you. The only problem is I forgot how to do it. I'm just going to look at my notes here. Always happens to me, Michael. I think we'll choose a nice easy one like an MD5. MD5 is not very secure, but with MD5, if you just want to use it to identify a file or a folder, just to give it a digital signature, that's fine. MD5 is very fine, but you don't want to use this to encrypt passwords. Sorry, not encrypt. You don't want to hash passwords using MD5 because there's a weakness there. It's very hard to do, but there is a weakness, there's a flaw. So this is the command file hash, and of course you can still do it the other way, but I just want to show you this way as well. And I did this nice and easy. The file path is there. I think I called it just what did I call it? It shouldn't be case sensitive, but because I run a lot of Linux commands, just out of habit, I like to make that capital. Sorry, case sensitive. I like to tab as well. I like to double check. All right, let's do that. There we go. So I've just hashed that. So I've got a unique hash for that file. Now look, check this out. Check this out. Right here. I'm only going to press the space button. Okay? Control S, save. That's all I'm going to do. Watch how this changes completely now. This is the power of the hashing algorithms. That's a huge change. That is nothing like that at all. That's how hashing works. Just a space, and it changes the whole digital fingerprint. That's interesting. Very interesting. Now, the reason why we want to do this is because we want to generate a hash value of malware. So you go out there and you get this app or you get this script, and you might good question, Michael. So very good question. So now what you do with this, there's a manual way to do this, and then there's an automatic way. The manual way is this file, I can save it off to a cloud or to other storage, and then I leave it. I don't want to touch this file. This file is just for storage, just storing stuff. I can now and then scan it again, and just like this one, if there's any changes to it, that means someone's altered it. Again, if you've got a file and you regularly set up a hash and you notice that the hash has changed, it could be a malware infecting it. It could be a malware doing damage to that file, changing, altering it. So you download, yeah. Correct, yes. Now, Michael, that's true, but you don't do that in the real life. You have this automated. You have SIEMs and you have other, you have a SOC center. You have other tools that automate this. But I'm just saying that this is what we can do. So we'll hash the file. If it gets altered by malware, then we can hash it again and see if there's any changes. Also, if you're downloading or if you're transferring that file to somewhere else, okay, you send it to somewhere else, and along the way, someone grabs that file, adds malware into it, and then on the other side, they get that file. Then what you can do is you can email them or whatever through Teams, I don't know, send them this hash fingerprint of it so that they can hash that same file on the other side. And if this is different, it means that something happened to that file. Perhaps the file it didn't arrive all in one piece. It happens sometimes. Sometimes it does happen, especially with audio and video. Or there might be malicious code in there. Or maybe there's something called steganography, which is some viruses embedded into the file. They're hiding, like a photo or video or audio. They're hiding some code inside that video or a zip or something. So this is why we use this hashing algorithm. The task actual. Okay, watch this, young Merga. Let's do it. I'm going to delete. I'm going to delete that space. Control S. I'm going to save it, and I'm going to run that algorithm again, and it returns back to its original fingerprint. Okay, it returns it back because it's exactly the same. Whereas if I put a space, look what happens to it. It doesn't just go 4577 and then 4577 5, 7, 8 doesn't increment. It completely generates a brand new randomly, not really randomly, but completely different hashing signature. This is a really important cybersecurity concept. Very, very important, because we can also track malware using hashing algorithms. We can actually hash a malware itself. So when that file comes into our system, our anti-malware can look at the hash of that file. Instead of scanning the whole file, the whole code, maybe running it in sandbox, which takes time, if a quick hashing of that app, program, script, whatever, if it matches a database of listed known malware, quarantine straight away. Now, most modern day malware is more intelligent than that. They can polymorph, they can change their form. They're much more clever these days, but not all of them. A lot of malware out there are still, doing what they have always done. Not much change, but you never know. So this is just, remember, this is security. This is multi-level security. This is what's the word? It's multi-layered security. So we're going to use security at different ways. This is one way we can do it. The other way is you can use AI to analyze the behavior of malware. That you can look at signatures within the code, within the script that looks like malware. There's heuristics. Heuristics is that, again, AI looking at the behavior. If the file is trying to get administrative privileges, trying to elevate, that's a classic behavior of a malware. And our anti-malware, if it's good, will stop it. We'll at least, at the very least, quarantine it or run it in a sandbox environment. Now, another one. Let's go over to, I'm going to use, I don't think this is connecting to an internet. Or maybe it does. So we go to virus, total. Now, I use this tool all the time, by the way. This is a very powerful tool. It's free. You can get a paid version of it. Means that, well, so I'm going to show you. I'll show you, Michael. Basically, you can do a few different things here. Well, we can't do that. let's do something. Virus total com GUI home search. Yeah, there we go. All right, so what we can do, there's a few things we can do here, Michael. We can add a URL into this, and we can get VirusTotal to scan that web address. Okay, this is a classic example. You know what? I'm going to do this. I'm going to do this live for you. I got a phishing email from Centrelink today. I did put in the trash straight away, but I didn't. I did not delete it just yet. I'm going to show you. Let's have a look. I don't know if this is going to work or not, but we'll see. I'm looking into my junk all the time, Michael. Every day I get that. Here, I'll show you. I've got one from MyGov Online. MyGov Online. So I'm not going to copy. I'm just going to type that address that they've got in there in the MyGov. Yeah, I'm just going to do www.employee. Now I don't know if VirusTotal will tell us that it is a naughty boy or naughty girl webpage, but let's enter that. Let's see. So this is a phishing attempt. Okay, let me prove it to you. So I use iCloud, and this is all my junk. This is all my crap. I just get crap coming in here, insurance, and I don't even know what this rubbish is. But this is the one, MyGov. Now this is clearly malware. I mean, even an uneducated person can check that out. But anyway, let's have a look. Let's see what. Wow, clean. They all say that's clean. Interesting. That's okay. Well, perhaps I haven't found it. Let's see if I can get another one. Another malware. No, no, mine's definitely clean. I'm vanilla. I am like old school, old fashioned. No way, man. All right. Milestone Nagasaki. Okay, I'm gonna copy that. Copy link. Let's see if I can whack that in there. Let's try another. Now maybe this doesn't. Yeah, this is clean too. Okay. Yeah, I've been fishy. They haven't detected it yet. Interesting. Okay, well, that's made a fool out of me, hasn't it? But yeah, these are brand new phishing campaign. But if you get an email that you suspect is a phishing campaign, try it. Whack that in there. You never know. Maybe it could be. Yeah, I'm so surprised that it hasn't detected that as malware. Interesting. Very interesting. By the way, what this does, VirusTotal, it connects to other vendors. So these are different. There's Kaspersky, which is worrying me now because I use it. So Sophos, that's very popular in businesses. Fishfort, it hasn't detected that as a phishing campaign. Oh, there we go. That's interesting. So that means it just goes to show you can't trust it 100%, but it's a tool, right? It's a tool. So now what we can do here is we can upload a file into here. Okay. Now let's choose a virus that we know there's a virus in there. Hopefully I can find it. Yeah, no, that's not it. Was it in here? No. I think I opened it last time. Hang on. Where did I put it? There it is. Yep, there we go. I think I can drag and drop. Aha, check that out. Look at that, Michael. Alert, 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 alert. Yeah? There you go. This is what you use VirusTotal for. This is a great way of analyzing files. All right, let's try it, Michael. Let's try it. Why not? We'll try that one. Well, Aaron, I think that first of all, this is a known virus. There's the signatures, there's key details of this. In the malware, it actually scans it checks the name. It checks the different parts of the file, and it looks at the signature. It looks for things that some of the code that actually looks like a virus, and then it sends it out to AVG and the other connectors, other vendors, and that's how it does that. Pretty quick. All right, let's check out this one here, which Michael has sent us. This one's taking longer, Michael. Okay. This is taking a bit of time. It's interesting. We'll let that cook for a bit. But that's actually it's actually having look at that. So suspicious, and it believes it could be spam. Sophos. You bet your bottom dollar that's a spam. The other ones think it's clean. That's interesting. We'll do that as well. Maybe we'll take that off. Maybe even take that off. See what we can get. It's still staying the same. So this time it's trust wave. So yeah, if I get a link like that, I'll be a bit worried. All right, what's next on our lab? Malware Bazaar. Malware Bazaar. We're going to use a different online service. So we're going to use a different one other than VirusTotal. Let's check out HTTPS. And notice that I'm not using my own computer for this. I'm using this virtual machine. All right, let's go to there. Malware Bazaar. No, I'm not a robot. I'm too slow and stupid to be a robot. Browse database. Yeah, you can browse it. We want to upload it, right? I think that's what it's asking of us to do. Search for, wait a sec. So wait a minute. Browse database. Search syntax. Oh, it's just telling us how to search for stuff. Yeah, these look like they're hash codes here. So remember how we hashed before? So let's do this. How about this? Let's hash this malware. Okay. Now you can use that hash calculator, but I like doing this. I like doing it this way. Actually, I should I what? Which algorithm should we use? What algorithm should we use? Probably what matter. I don't know actually. I do not know. Let's just hang on. Let's go back up again. You know what? Let's just do MD5. Let's see what happens. We're all doing it at the same time. So what was that location? There we go. And hit that. I don't think it found. Oh, didn't work because I have a different name than what we have. Sorry, wait a sec. Rename. Copy. There we go. So now the hash of that, an empty hash of that one, I'm going to copy that. And let's test that now. So we don't even have to upload the whole file. We can hopefully just add just that hash, I hope. Yeah, see MD5. Yeah, there we go. So let's do that. So MD5 colon and then paste that. Now I don't know if that's going to be a problem because it's in hexadecimal. Not sure if that's going to be an issue. Let's search for that. That didn't work. So we might have to convert that to lowercase. Yeah, oh no, actually here, it's got uppercase. Should be okay. Why did that work? Okay. Oh, that was just an example before. Wonder why that didn't work. Okay. Okay, let's follow the instructions this time. I'm trying to be fancy and do it my own way. We'll follow instructions. We'll use the hash calc. From the right top button of the data field, navigate to the path of the lab2.exe file. All right, let's go back to the exe file. Okay, we'll unzip lab2. Oh, what was the? Does anyone know the password to this? I can find it, but infected, yeah, infected. Okay, so that's the file there. I'm just going to see if this is going to work. I'm going to see this one. Should be okay. I don't know why it wouldn't be. That didn't work. That wasn't good. Let's try that again. Copy. Oops. And we then select, it was lab 2, wasn't it? Hang on. There we go. Right click, rename. It's always a shortcut to doing stuff. Copy. And then we'll whack that in there. All right, so that's the hash for that. All right, let's try MD5 colon, and we'll search for that. Yeah, it doesn't like me very much. So let's do it. Let's do it the other way. We'll go to hash calc. We'll go to file. There's that file location. Okay, user, student. I hate that old Windows system. User, system. Sorry, users, student, not system, student. And malware something, wasn't it? Yeah, malware sample. Lab 2, there we go. Open, MD5 SHA-1, calculate. Now, I got exactly the same thing, didn't I? So why did that not work? I don't know. All right, let me copy the SHA-1. Maybe we'll get a result for SHA-1. You know what? I don't think this is gonna work for us. All right, no problems, no worries. Can't find it there. Anyway, I was hoping, what I was hoping to do, and I like to go off the lab a little bit because it's boring sometimes just following instructions all the time. I never read the instructions for like setting up a television or the IKEA, and that's probably why the legs on the IKEA is backwards, because I don't follow instructions. But let's have a look. Let's go to syntax, and if we just choose this randomly here, this SHA-256. I was hoping that the virus that we have would match the database here, but unfortunately it doesn't. So, but this is an example of the database with that particular SHA-256 hash. If we click on that, it'll give us more information about that malware. It's a rat. Don't like rat. Remote access something. Remote access, remote something. I don't know. Remote access threat, I think. I forget. But that's the signature there. There's the different hash algorithms there. This is what it looks like, and then it tells us more information. It's mouse. It's a spam. That's just one example there. All right, so I've skipped a few things here. I'll leave it for you guys to follow through. Okay. Yep. I'll let you go through the rest. Now, the rest. I'm going to leave the rest for you. But this is a good tool. I was just hoping that our malware would come up there, but it didn't. Now, I'm going to show you a wonderful tool. This one, I really want you all to bookmark this. Really, really bookmark this. This is amazing. Okay, this really, really is amazing. The MITRE ATT&CK framework. Okay, pen testers use this, and so do attackers, malicious attackers, bad actors. I'm not talking about bad actors like what's his name? Like Tom Cruise, terrible actor. Not that type of bad actor, a threat actor, bad guy, the hackers that do things for bad reasons. This website here, and please copy this website because it's a wealth of information. It tells you how attackers, what strategy they use to attack our systems. So I'm going to give you a brief overview here. It's like the army. It's like war. The first thing, if you ever read The Art of War by Sun, what was his name? It's a great book. It's in the book The Art of War. The advice is when they're going to war is to go and gather information about your enemies, know as much as you can, reconnaissance. So the malware that gets sent to us will start doing things like active scanning, gather information, gather ID, network. It'll gather as much information as it can and send it off to a command and control computer out there in the world. So this is the framework. And if you want to be a pen tester, or if you work on the blue team and you want to defend your network, you can do this in reverse. When you can defend your networks by understanding that if you detect in your SIEM or in the SOC center that you're working at, if you get an alert that someone is scanning the system from a remote location, now it happens all the time. There are bots everywhere that scan our web servers, but if you're getting a scan on your SQL server, or if you're getting a scan on your file server or your Active Directory server or your Windows 10 machines, that's a problem. But now that you know that this is a technique, a strategy that attackers use, then at least you can do something about it. And screaming around, running around, panicking, that's not what you do. You do something else. There is you have a plan ready for that. Okay. I have spent hours and hours and hours looking at this. I lost track of time once. There's so much stuff in here. It is so well done. Now, excuse me. This MITRE ATT&CK is the opinion of MITRE, this organization. It's their opinion on how these attacks are set up. It's up to them. We don't, as cybersecurity experts, we do not have to believe this or follow this if we don't want to. It's just an opinion. It's just a framework. It's not legally imposed on us to follow these. To follow this. There are other frameworks around, but to be honest, between you and I, use this. So phishing for information. Here we go. Adversaries may send phishing messages to elicit sensitive information that can be used during targeting. Phishing for information is an attempt to trick targets into divulging information frequently. That's just a fancy way of they want to trick you. They want to grab information from you any way they can. So that's that one, and then it shows you. It tells you the procedure on how they do that. Matt, after we finish this, come here. Instead of watching, what's the latest? What's on Netflix lately? Forget Netflix for today and read this. Outer Bank. Oh, okay. I just finished I finished Silo, the series on Apple. That's actually pretty good. That's actually really good. Good series. Can't wait for the second one. But anyway, what am I saying? No. Don't watch Silo. Go here and read this. No. You will, Michael. You will be coming to this website and you're going to read all this. No, I'm not joking. We all need to. We need our what do you call it? Our brain needs a break from reality sometimes. Now my connection is going poor for some reason, so I'll try to talk quicker, I guess. And then there's resource, initial access, content injection, user execution. Wow. Boot. Oh wow, look at this. Deploy containers, defensive evasion, credential access, credentials from password store. Now check this out, Michael, and everyone else. Now, all of them, Michael, all of them. But this one here, this one is about credentials for password stores. So this is worth spending time on. I'm going to spend a little bit of time on explaining this because look, you guys, you can do the labs. You can just follow instructions, and that's easy. Like anyone can do that. But I want to show you some really, really cool information. And malware can do this. Really, really well thought out malware can run by itself. Yeah, sure. Go ahead, Michael. Go ahead. Whenever you're ready. I can't hear you. Anyway, I'll keep talking until you figure a way of unmuting. So when you log on to Active Directory or Linux or whatever, you're asked to put your username. And Michael, when you get your mic fixed, just yell out. I'll stop when you yell out when you're ready. But you put your username. So this is Active Directory. You know when you put your username and login when you log into a Windows machine, you put your password in. Say that's your password. Do you think, who thinks that these details are stored in a database in Active Directory somewhere like that? You got tables and that. And that is, do you think that's how our passwords are stored in our Active, where Active Directory stores this, okay? Or Linux, whatever, the password file. Do you think that's how the passwords are stored? No, absolutely not. Absolutely not. What happens is these are, the password is actually hashed. And now I checked this with Ubuntu. The hashing algorithm is something I never even heard before. It is a very, very powerful hashing algorithm that I don't believe can be cracked ever, unless there's quantum computing involved. Ubuntu hash password file. I think sorry, the shadow file, not the password file. Shadow file. I'm just trying to think of what type of algorithm they use now. I'm gonna cheat now. I'm gonna ask ChatGPT, what type of hashing algorithm does Linux use for the shadow file? Now it's not MD5, not SHA-256. It's not SHA. It's saying maybe blowfish, but I don't believe it. I think ChatGPT is wrong. That's why you don't trust ChatGPT because it's not right. It's not blowfish. It's something else. It's not SHA-256. It's more powerful. But anyway, sorry. So over here in our shadow file, this will be I'm just going to write ABC123. That's the hash. So what happens is this. When you enter your credentials, your username and password. Your username, yep, that's correct. That's a tick. The password is hashed using whatever algorithm. And it's hashed from this, and it turns it into the hashed signature for that, 1, 2. Then it compares to that hashed over there in the stored database. So this is what's happening. This is why we use hash. Now, if we're looking this over here, so this is credentials from the password store. There are ways, there are tools that can grab those passwords. Now, you've got FTP clients. They're not encrypted at all. There's no encryption there, or very little encryption. There are other tools as well that can grab those credentials. These seem to be from, yeah, okay, Windows Credential Vault. This is what I'm talking about. Stealth Falcon. It's storing it from the Microsoft Vault. Malware uses WMI to script data collection and command execute. Wow, I don't even. RC4. Wow, it's pretty cool. So this Stealth Falcon is a tool that can grab that password from the Microsoft, sorry, the Windows Credential Vault. Okay, Michael, you okay there, or? No, I can't. I cannot hear. I'm sorry. No voice. Don't think so. Can anyone else hear Michael? Maybe. Yeah, no, sorry, I couldn't hear Michael. Sorry. That's a MITRE attack. You need a long time to look through that. You're gonna need lots and lots of time. Ah, Michael left. Now, there is another website that's kind of interesting, and it's called app.any.run. Now, this is, yep. Yeah, Michael?
Oh, yeah, cool. Yeah, I don't know what was going on.
Gotcha. Yeah, I've got you.
Do you mind if I ask a question, or are you in the middle of
Yeah, sure, no, go for it.
So do you know the virus total that we were on before? On the lab, it says, so what I've done is I've generated the hash values using hashcalc for the file, and I copy and pasted that into virus total, but because I know you said that MD5 is obviously less secure, but I copy and pasted the like SHA-2561, and the website still brings up all the viruses. So does that mean that, like, can this website read the hash value file? Because I thought there was like more secure versions where, like, no matter what, you won't be able to open it and read it and see if there's a virus or not. So I just want to know if, I don't know if I missed.
No problems.
Yeah.
Okay, I'll go back to hashing 101. Hash 101, and not the type of hash that is now legal in California and other states. Not that type. Not the type that you eat at McDonald's, and not this one here. What we're talking about is a way of running any set of data, any zeros and ones, and so these zeros and ones, okay, that is in clear text. So this is clear text, right? Sorry, you know what? No, I'm not going to go there. Let's not go there. So this is zero. So this is converted. Sorry, these are a set of binary. Okay. We're going to run. So it could be a file with hello in it. .text. It could be a file with every single book in the entire galaxy. It's like a 1 trillion terabytes in there. Could be a virus, 1.5 megabytes. With an MD5, how many characters are in the MD5? I'm building up to your answer. First, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I should know that by heart. I'm supposed to be a cybersecurity expert. I forgot that. So 32 bits. Sorry, not 32 bits, 32 hex characters. So 32 in hex. Okay, that's the length, 32. 32 times by 4, by the way, because hex is each hex character is 4 bits. So what's that? That's 128. So 128 bits. So MD5 is 128 bits. Okay. Now this hello text file, I don't know, it's like 5 kilobit, I don't know, whatever. And this is like 1 trillion bytes. If we run a hash MD5 algorithm on that, or this virus over here, we will always get the same length, 128 bits. So this is what I'm going to tell you. This is how I'm going to tell you this, Michael. So okay, I'm 6'3", 190 centimeters. I won't tell you how much I weigh, more than 100 kilos. I've got blue eyes. I've got gray hair now because I'm getting old. I'm wearing a blue t-shirt at the moment. So if you could run a hash algorithm on me if you wanted to. Well, it won't work because I'm human, but it's basically my DNA, right? So that DNA is only me in the signature. Okay, it does not contain data in there. A hash, this hash algorithm here, okay, it's not encryption. We're not encrypting anything. Hashing is not encryption. Very important. So, what's this? Buzz off. What is this? Buzz off. Okay, this only contains a digital signature. Just pretend you're signing your name. It only identifies you. It doesn't contain you in it. I cannot reverse this and get you back and turn you back into a human. It's only a signature. I can get a virus, malware, and I can hash it and I can get a signature of it. So it doesn't matter how much you run the hashing algorithm. It doesn't matter how hard you run it. Yeah, it's not going to make us safer or unsafe. It's just identifying it. Yeah, there's no information and no encryption at all. It's just identifying what that set of zeros and ones are. Now, having said that, Michael, having said that, that example I used before, I think I got rid of it. When I'm hashing a password, that's important to use a stronger algorithm. That's when you use a stronger, because MD5 is easier to crack. So there is a way to reverse engineer old hashing algorithms by using rainbow tables. There's other techniques, but it's cheating. It's not actually rebuilding it from nothing. I don't know if we talk about that in this unit, but there are ways of doing things. Yeah. All right. Awesome. Cool. Good question about that. That's a really good question. That's a very tough concept to get. So if you can get that, that's I'd be impressed. Encryption and hashing algorithms, they're similar in that they run through algorithms and formulas, coding, but they are different. You use encryption to hide stuff. If it doesn't have any info, it won't detect it. Yep. So if we hash a virus and virus total does not have it in its database, then it won't find it. It won't compare. It won't be. Yep.
Oh,
It's
okay,
like,
sorry.
yeah.
So if I have a 300-word file and
Mhm.
wshex.dll is in that file and I upload it to VirusTotal and it gives me, it will say it's a virus. But then I go into the file and I add a space bar and save it. It's a completely
Yep.
different hash. So would VirusTotal
Yep.
still pick the virus up?
So that's a good question. So now, someone's thought of that before you already, but I like your thinking. But this has already been thought of. But this is, I like this. So you run the hash. So okay, so you get a virus, and it's got, I don't know, it's got a virus in there, and then you just enter a space bar or whatever, then hash it again. Now, yeah, you can manipulate that and then send it to VirusTotal, and VirusTotal may not pick it up. Okay. Now, VirusTotal and the other, where is it? I'm sorry, wrong window. VirusTotal and the other website, which I've named it Malware Bazaar. Yes, they do use hash. They do. Fair enough. But they use other techniques as well. It will use other things like file types, malware traffic, behavior, Yarra rules, serial numbers. So it's not just using hash, it can try other things like signatures. Within the virus itself, within the virus, we might change the size, and it gives us a new hashing, a new hashed value, but there is behavior in this malware. This is malware, right? And I know my writing's atrocious, but there's certain behavior, there's certain signatures that a virus contains. So sometimes, not always, VirusTotal and okay. So if you're going to send a hash, you change it, it won't detect it. It won't detect it based on that hash value. That's why you don't rely just on the hashed version of the malware. You try other things as well. Yeah. So it's just one thing you can do. The where I would use hash is when I get a file and I want to send it to someone, or if I want to store it, then I would compare the hash. But when it's in terms of this, yeah, there's other things that you do as well. These days in modern with AI, with modern firewalls and endpoint detection, and also deep packet inspection, all that kind of stuff. They can actually observe the behavior, even if it's hashed, even if it's encrypted. You can still observe the behavior. It's really interesting. All right, that's all I've got for you today. I've run out of time. So next week, you can do the rest of the lab here. It's not that hard. It's pretty easy. But next week, I'm going to change the time to 6:30. Okay, I'll do that as soon as we finish. As soon as I close this, we're going to finish 6:30 next week. All right, everyone. I'm going to end the recording now, and I will see you all next week, 6:30. Thank you, everyone. I'm ending the recording now.